Section 5.8 is on inverse trigonometric functions doing integration, so anti-differentiation. Again, this starts off by looking at the differentiation rules that we proved in previous sections. We know that the derivative with respect to x of the inverse sine, which is this book calls the arc sine of x, is 1 over the square root of 1 minus x squared. We know that the derivative with respect to x of the arc cosine of x was negative 1 over the square root of 1 minus x squared, and then we used the a's and the u substitutions, and so here it breaks down to these three rules right here. The ones that you really needed to know were arc sine, arc tangent, and then there was one for arc secant as well. And then remember, if you had cosine being arc cosine, arc cotangent, or arc cosecant, the only difference between those functions, the co-functions, was the negative sign out in front. So if you remember, the only difference in between them was the negative sign out in front. Okay, so let's look at the first one right here. Let's look at the rules. It says the integral of du, so this is, we'll get to that in a second, so it's essentially 1 over the square root of a squared minus u squared is the arc sine of u over a. So we actually have two substitutions here. We have to substitute in a u value and an a value, and that's equal to the arc sine of u over a plus c. We have number 2, which is the integral of du over a squared plus u squared is 1 over a arc tan u over a plus c, and then 3, the integral of du over u square root of u squared minus a squared is 1 over a arc secant of the absolute value of u over a plus c. And then if you have the negative sign, you could just pull that negative sign out in front. Okay, so let's look at number 1 here. It says find the antiderivative with respect to x of 1 over the square root of 4 minus x squared. So in this case, I notice immediately, I'm looking up top, there's no x's, so I know this is not a u substitution problem. The only u that we could use here would be the 4 minus x squared, so we would have a derivative of negative 2x squared. That's not going to simplify with anything here. I don't have any tricks up my sleeve here. I have to realize that this is one of those trig rules. So if you're allowed a note card, I'd be putting all of these antiderivatives most definitely would be on my note card. So this is of the form the integral of du over the square root of a squared minus u squared. That's what this is of the form of. And let's double check that here. We're going to say this is a equals 2 and u equals x. So notice this here, and then I'm just going to note that du dx would equal 1, which would say that dx equals du over 1, which is simply du, right? So we do have our substitutions here, but now we need to be careful what we're substituting in for. We need to substitute in for a, we need to substitute in for u, and we need to substitute in, sorry, I should use my regular colors that I've been using the whole time. U was red, and we need to substitute in for dx, okay? So when we rewrite these, let me erase what I wrote right here. Well, no, this is, go back. This was step 1, identify u, except now step 1 is identify u and a. Step 2 is take the derivative of u with respect to x. Step 3 would be solve for dx. So step 4 would be rewrite the integral in terms of u's and a's. So this is going to be the integral of, instead of dx, we would have du. Instead of the square root of 4, that would be the square root of a squared, right? And instead of x squared, that would be u squared. And this is exactly the integral that we wanted to be able to use the rule. So we've shown that we've made it fit the rule so we can apply the rule for integration. If we apply the rule for integration, let me zoom out a little bit so we can see this. This is equal to the arc sine of u over a plus c. Well, now we can back substitute for our a value, which was a 2, and our u value, which was x, and rewrite it. In step 6, rewrite the integral as the arc sine of u, which was x, over a, which was 2, plus c. So again, the final answer is the arc sine of x over 2 plus c. Okay, So let's take a step back and realize what was different from this problem from all the previous problems. And the answer is nothing. It's still a U substitution problem. It's still the same 6 steps. The only additional part is that we had to back substitute for A here. So we had to do a substitution with A as well, okay? So these problems, what's the key to these problems is just noticing that is one of these 3 arc trigonometric functions, the inverse trigonometric functions. So you just have to realize it's of that form to be able to do it properly. We'll see a couple more examples on the next page.